welcome. On atoms I have made 3 videos. This is the 4th video, part 4. In the last video, part 3 video, I have completed the drawbacks of Rutherford, and here I am explaining the drawbacks of Rutherford atomic model. The first drawback is it could not explain the stability of an atom, and second one, it could not explain the origin of spectral line. Let us see why the Rutherford atomic model could not explain the stability of an atom. We know that according to Rutherford, electrons are revolving in an orbit, right? They move with a certain acceleration. They are moving with certain acceleration. Then, according to electromagnetic theory, classical electromagnetic theory, any particle moving with the acceleration, it must radiate the energy. Any particle moving with acceleration emits radiations. Then, if it is emitting the radiations, it loses its energy. When it loses its energy, it starts coming towards the nucleus in a spiral path, and after that finally it will collapse with the nucleus. If one electron collapse with the nucleus, then there is no stability of an atom. Hence, the Rutherford atomic model could not explain the stability of an atom. The second one, it could not explain the origin of spectral line also. Before that, we know that using Rutherford, we have derived one equation for energy of an electron which is revolving in an orbit of hydrogen atom in terms of radius. That energy equation is E equal to minus ZE square upon 8 pi epsilon naught r, where r is the radius of the orbit, which is not the Rutherford did not found this value radius. If he have the value of radius, then he could able to find out the energy of an electron which is revolving in orbit, but he is unable to find out the radius. Hence, this theory could not explain that radius of the orbit, and also it could not explain the origin of spectral line. How exactly? If an electron revolving in an orbit, it emits a radiation. If it is emitting the radiations, it must emit the radiation in terms of increasing in frequency, and it also must provide then almost all possible wavelengths, correct? But there must be a continuous. If it is such continuously emitting the radiation, energy means it must continuously produces the spectrum. But in practically, the radiations are line spectrums, not a continuous spectrum. They are a line spectrum. Hence, it is unable to explain the origin of spectral lines. Yes. To overcome the drawbacks of Rutherford atomic model, one more scientist, his name is Niels Bohr, he changed the Rutherford atomic model slightly, and he gave some postulates about the atomic model. That is called Niels Bohr's atomic model, and the Bohr's postulates are there. He gave 3 postulates. The first one is, he just altered the Rutherford atomic model only. According to Rutherford, the electrons are revolving in the orbit around the nucleus, correct? With radiating energy, correct? Like that he said, Rutherford. But Niels Bohr assumed that, or he said that the electrons which are revolving around the nucleus, right? They revolve in only certain orbit, and that too without emission of radiant energy. Such orbits are called stationary orbit. That is the first postulate. That is, the electrons revolve in only certain orbits called stationary orbit, and in these stationary orbits, the emission of radiant energy is not there. They are not radiating the energy. Correct? That is the first postulate. That means if they are not radiating the energy, that means they are not losing energy. They are not going to fall into the nucleus, and they are sustained. That's why the atom is said to be stable. Second one, the angular momentum of electron in the stationary orbit is integral multiple of h by 2 pi. Here, the electron which is revolving in a orbit will be a angular momentum. Momentum means velocity and mass. Anyway, electron has a mass and it is moving with a constant velocity in an orbit. That means it has some angular momentum, and that angular momentum is equal to the integral multiple of h by 2 pi. H by 2 pi. That is, angular momentum can be given by L, which is equal to mvr. M is the mass of an electron, v be the velocity of an electron, r be the radius of the orbit, and which is equal to n into h by 2 pi, where n is an integer, first orbit, second orbit or third orbit, and h is the Planck's constant, 2 pi is the one complete circle, 2 pi, right? Next, the third one, the electron emits energy only when it jumps from outer orbit, nothing but higher energy, to inner orbit, nothing but lower energy. To explain this one, I'll consider this as a nucleus, and this is first orbit, second orbit, third orbit, like that goes. Now here, the first orbit energy is E1, second orbit energy is E2, third orbit energy is E3. If suppose electron jumps from higher energy orbit, here E3 is the highest energy, E2 is less than E3, and E1 is less than E2 and E3. So here E3 is the highest energy, E2 is the lowest than E3 but greater than E1. Now I'll assume that electron jumps from E2 to E1. Electron jumps from E2 to E1. At that time it emits the energy. That energy is given by E, which is equal to difference in this orbit, difference in the energy of these two orbits, that is higher energy orbit, which one is among these two? E2, that is E2 minus E1. This much amount of energy radiated when the electron jump from higher energy orbit to the lower energy orbit, and this also can be given by h nu, which is equal to E2 minus E1, where h is called Planck's constant and here nu is called frequency. Nu is called frequency, radiated frequency, energy whatever radiated, that frequency nu. So these are the three postulates of Niels Bohr's atomic model. Yes, as Rutherford could not able to find out the radius of the orbit, but Bohr's atomic model able to find out the radius of that orbit, first radius of the hydrogen atom's orbit, first orbit radius we are going to find out here. So to derive that expression, the expression for the radius of nth Bohr orbit of hydrogen atom using Bohr's postulate. To understand this, or to derive this equation, consider the nucleus with a positive charge plus Ze and the radius r, and there is a orbit with radius r, and in this orbit electron is moving with certain velocity v and electron e, and it has a mass m. Then from this figure I can write, from figure you can write what is plus Ze here. Plus Z is the charge of the nucleus, charge of the nucleus. Next, r with the radius of orbit, radius of orbit. I'll assume that the whatever we are taking here, that is a hydrogen atom, which has only one orbit. We are taking example of that one. The r be the radius of orbit, and next e be the electron, m be the mass of electron, mass of an electron. Next v be the velocity of electron, v be the velocity of an electron. So these are the some important information from the diagram. And also we know that for stable orbit, already we have studied this also, still I am writing here, for stable orbit centripetal force must be equal to electrostatic force. I am writing in short form, centripetal force equal to electrostatic force. What is the centripetal force here? Centripetal force is m v square upon r is the centripetal force, which is equal to electrostatic force between nucleus plus Ze and electron in the orbit E, that is 1 by 4 pi epsilon naught Ze square upon r square. This is equation number 1. Or still more I can further calculate this one. that is mv square upon r, which is equal to z square upon 4 pi epsilon naught r square. Here r is there, here r is there, so one r will get cancelled, one r remaining here. This r I will bring here, therefore mv square r is equal to z square upon 4 pi epsilon naught. I'll call this one as equation number 1. Next, from Bohr's atomic model, second postulate, using that if an electron revolving in orbit, it have an angular momentum. That angular momentum is given by mvr, which is equal to nh by 2 pi. We know this one, right? Now squaring squaring on both sides, right? Squaring on both sides. What happens? Squaring on both sides means m square v square r square, which is equal to n square h square upon 2 square means 4 pi square. This is equation number 2. Now divide equation number 2 by 1. Divide equation 2 by equation 1. That is, if you do so that here m square v square r square upon m v square r, which is equal to n square h square upon 4 pi square whole divided by this equation ze square upon 4 pi epsilon naught. This I'll alter and I'll write here. So here what will get cancelled? 1 m will get cancelled, v square completely will get cancelled, 1 r will get cancelled. What is remaining here? 1 m and 1 r will be remaining. That is m into r is remaining here, and here I'll write n square h square upon 4 pi square into, I'll write it in reverse manner, that is 4 pi epsilon naught into divided by z square. Correct? Now what will get cancelled here? 4 will get cancelled, 1 pi, here pi will get cancelled, and I'll, because we want a radius, so r I will keep here only, m I will bring that side. Therefore r is equal to n square h square, correct? And here what is remaining? Epsilon naught divided by, here 1 pi is there, and here ze square, and here 1 m comes here. So by rearranging the equation for nth Bohr orbit, Rn is equal to n square h square epsilon naught divided by m pi ze square. This is the equation for radius of orbit of nth Bohr orbit using hydrogen atom using Bohr's postulate. If you want to calculate what is the value of first orbit of hydrogen atom, what is the value of radius of first orbit of hydrogen atom is, if you substitute n is equal to 1 and z is equal to 1 for hydrogen atom, then radius of first orbit of hydrogen atom is h square, because 1 square is 1, epsilon naught value you have to substitute, mass of electron pi, z is 1 value, and e square. If you substitute all these values, because we know all these values, Planck's constant value is around 6.67 into 10 to the power of minus 34, epsilon naught value 8.854 into 10 to the power of minus 12, mass of the electron 9.1 into 10 to the power of minus 31 kg, pi 3.142, e electron value 1.9 into 10 to the power of minus 19 coulombs. If you substitute all these values, you get R1 is equal to 0.53 angstrom. Nothing but the radius of the first orbit is said to be 0.53 angstrom. In general, we can find out the radius of any orbit of the atom using this formula, that is Rn is equal to 0.53 n square upon z. This is the formula. From this equation we can say that radius of an orbit is directly proportional to the square of the orbit number, and radius of an orbit is inversely proportional to the atomic number. These are the two important information in this video.